So now in number 3, I'm trying to find the slope of the tangent line at any x value. So if I was trying to do it at x equals 2, then I would be plugging in 2 for these x's here. If I was looking for it at 2, then I would be plugging in 2 for these x's here. But since I wanted at any x value, this is just going to stay x because it doesn't matter what my point of interest is at this point. So for this function, that becomes the limit as h approaches 0. F of x plus h is 2 times x plus h squared minus f of x, which is 2x squared, all over h. So if I FOIL this binomial, I have the limit as h approaches 0 of 2 times x squared plus 2xh plus h squared minus 2x squared all over h. So coming down here, now I have the limit as h approaches 0, distributing 2x squared plus 4xh plus 2h squared minus 2x squared all over h. And then these 2x squareds cancel out. So I'm going to do somewhat like 2 steps in one here. I see that these two terms have a GCF of h, which can cancel with the h in my denominator. So I'm going to factor that out. H, and that leaves 4x plus 2h over h. And now my h's cancel. So now I have, let's just go down here, the limit as h approaches 0 of 4x plus 2h, which approaches 4x. So that is the slope of my tangent line at a general x value. So think about that. That means at any x value, I find the slope by multiplying by 4. Well, let's look up here. At x equals 2, 4 times 2 is 8. So you could have found the general equation and then plugged in your x value as well. So there's quite a few ways to get around to finding the slope of your tangent line.